Graphing in the form ax plus by equals c. So last day we took a look at graphing in the form y equals mx plus b using the slope and the y-intercept, but what if the function that we're trying to graph isn't in that order? It's not y equals some number of x's plus b. What if it's instead, say, 3x plus 2y equals 6? And we have a number of options to try and solve this. You could go and make a table of values. So you could say, okay, let's make a table, and I need some x values and some y values, and you could start just guessing. So what happens if x is 0, and then, well, you have 3 times 0 plus 2y equals 6, so that's 0 and 2y is 6, which is 2y is 6, which means y is 3. So you can slowly fill in your table this way. What happens if x is 1? And then do the work. 3 times 1 and 2y is 6, so that's 3 and 2y is 6. Subtract 3 on both sides, divide by 2, and get 1.5. But this takes a long time to do. You actually don't need very many points because everything that we're doing in grade 9 and almost everything we do in grade 10 is linear, which means it's a straight line. So as soon as you have 2 points, it's very likely you can draw a line between those 2 points, and that line will contain all the other points that are in the table. But it still is time consuming to do this, and there are 2 other more elegant approaches to this. So let's take a look at option 2. So option 2 is you could convert it to what we were doing last day, try and convert this to y equals mx plus b. It seems a little bit like cheating, but you should be able to take a formula like 3x plus 2y equals 6 and solve it for y. Make it just y equals. So subtract 3x on both sides, and that would give me minus 3x plus 6, and then divide every term by 2. So divide the first one by 2, divide the second one by 2, and divide the last one by 2. Before we go any further, why would I choose to leave this number as negative 3 over 2 and not as negative 1.5? So see if you can think about a reason why a fraction would be better than a decimal in this case. Okay, well, let's continue. I'll give myself some more space and add a little graph in here. So when I go and graph this like I did last day, I just walk through those same steps. So I start with my y-intercept. The y-intercept is the b, it's plus 3. I draw a dot, and then I work with my slope, and my slope is negative 3 over 2, which is rise over run, and hopefully this is helping answer that question. And so I go down 3 and to the right 2, and down 3, right 2, and down 3, right 2, and down 3, right 2, or I go backwards, up 3, backwards, left 2, up 3, left 2, and then I get out my ruler, and I draw a nice straight line through all of these points to the edges of the Cartesian plane with arrows to show that it continues forever. So we can convert them to y equals mx plus b and then graph it from there. There is another option. Again, all 3 of these options will produce this same graph. So let's take a look at this third option, and I'll keep this graph here so we can continue to see it. So option 3 is to find the intercepts. So 3x plus 2y equals 6. That's our graph. And intercepts are where the line that we're drawing meets the x-axis and meets the y-axis. And specifically, we've got where we meet the x-axis, this will be the x-intercept. I'll just put x-int. And where we meet the y-axis, that will become our y-intercept. And they have very specific coordinates. So if I just look at that point on the graph above, I move over some amount x, and then I don't go up or down. So you'll see that the y value is equal to 0. Whereas with this y-intercept, I don't move left or right at all, so my x value is equal to 0, and then I move up or I might move down. In the case of b being negative, I might move down. So we've already seen a y-intercept before. I'm just adding the fact that it has a coordinate that's 0, y. And that means that the x value is always equal to 0, and the x-intercept has a coordinate x, 0, and therefore the y value is always 0. And that's what we're going to do to graph this, is we're going to go find those x-intercepts and the y-intercepts. So if I had started from the first step of, okay, 3x plus 2y equals 6, and I try and find my y-intercept, well, the y-intercept happens when x is equal to 0, so I make x equal to 0. And I did this in the table of values above, so this should be pretty fast. I get y is equal to 3. So the coordinate of the y-intercept is don't go any in the x direction and then go up 3, and you end up at the y-intercept. Then, if I do this for the x-intercept, now I start off with 3, but now y is equal to 0. So 3x and 2 times 0 is 6, and that's 3x is equal to 6, or x is equal to 2. And so I have a y-intercept where x is 2 and y is 0. And if I take a look at that graph that I have above, I can see that the x-intercept is actually at 2, 0, and this y-intercept was at 0, 3. And all I have to do as my final step when I'm graphing these is graph these 2 points and then connect the dots, which is an extremely fast method because we only have to do 2 substitutions. The substitutions are usually fairly easy to do because we're substituting in 0 for the variables, and just solve for the other variable. And then play connect the dots with your ruler. The bad news is we only have 2 points, so if you make a mistake, you're going to have the wrong graph. But the same thing's really true for option 2. If you don't know how to graph the y-intercept and use the slope, you're going to have the wrong graph. And option 1 just takes a long time to graph more than 2 points. But those are your 3 options. I would suggest you learn all 3 because we will be needing them not just this year, but we'll be needing all of those tools in future years as well. Let's take a look at a little bit of a spin on this. Let's try graphing y is equal to -2. Well, option 1 would be to make a table of values, and if I make a table of values, I start listing out x values and y values, and you can make your table across the page, or you can make them up or down. You just have one rule, and the rule is x is -2. So y is -2. So no matter what I pick for x, y is -2. And I really don't need too many points for this. The rule always stands that y is equal to -2. Let's plot it and see what it looks like. So 0 and down 2, -3 and down 2, 5 and down 2, and then connect those with the straight line. Oh, doesn't look too bad, and that's exactly what I wanted the graph to look like. Okay, let's take a look what we would get if we did option 2. Option 2 is to turn this into y equals mx plus b. Well, it basically is y equals, there's just no x's, and then it's -2. So the -2 tells us that the y-intercept is at -2. Great, got that point. What does this tell us? Well, it tells us about the slope, and it tells us the slope is 0, which really means 0 over something, 0 over 1. And remember, that's our rise compared to our run. So that means don't rise any, but then run. Don't rise any and run. Or do it backwards. Don't rise any, but run backwards. Run backwards. So you can go left or right, but don't rise any. Don't go up and down at all. So another option to graphing y equals -2 is to think about it as y equals mx plus b. The third option, which I just showed you, is to try and find the x and the y intercepts. This gets a little bit tricky. I can see from the graph already that there are no x-intercepts because there's nowhere where I don't solve for an x if I put y equals 0 in there. In fact, y equals 0 into the equation is not true. So there's got to be a problem with that. But x equals to 0 in the equation totally works. That gives me the coordinate if x is 0, y is -2, and so I get 1 point. So unfortunately, this ax plus by equals c method does not work for this kind of graph. It's a pretty good method, but again, as I said, we do kind of need all three methods. Let's just take a look at one other example, and then we are done. Okay, so in this case, I've got x is equal to 1. So if I use my first method and I make a table of values, I know x is always 1 no matter what y is. So I could try and plot those points. That would be the table of values way. A second option is to try to make it into y equals mx plus b. Unfortunately, x equals 1 doesn't have a y in it, so it can't be made into y equals mx plus b. So we've got something strange happening here. And the third method also won't work very well because I can get an x-intercept, but I can't get a y-intercept. So for the y-intercept, try and make x equal to 0. Well, you have your problem. But for the x-intercept, where you make y equal to 0, okay, y is 0, that means x is 1, therefore I have the point 1, 0. So I know it goes through 1, 0. In fact, I had that point on my table of values. I also know it goes through 1, -2 and 1, +2. And if you take a look at this graph, it goes straight up and down. Now, why didn't y equals mx plus b work? What's the slope of this graph that goes straight up and down? Well, the slope again is rise over run. And I rise some amount, but I'm not running at all. I'm not going left or right at all. There's no change in the x values. They have to be 1 every single time. And this is where we get a problem in math that we call an undefined number. And because the slope is undefined, it can't be written as a number, and therefore we can't write this as y equals mx plus b. So in summary, we've got a strategy for ax plus by equals c, where we can make a table of values, or we can try to make it into y equals mx plus b, or we can find the intercepts. And we need another strategy if y equals something. We have a straight line that goes this way, and x equals some value is an undefined line that goes straight up and down through the value of x. So there's a quick little summary for you, and we will see you in class.